Radiometric method. Surveys, also known as gamma ray spectrometry, are an airborne method which measures the amounts of natural radiation produced at the Earth's surface. Radioactive uranium, thorium, and potassium minerals occur naturally in rocks, producing relatively high amounts of radiation which can be measured in contrast to the surrounding rocks. Due to gamma radiation only being able to penetrate several centimeters of ground, radioactive minerals must be present in outcrops to be detected. Though through atmosphere, these rays are amplified to a couple of hundred of meters. Hence, low-flying aircrafts are useful for covering large regional areas. Because of the energy of gamma radiation received is distinctive of the specific element, it can be useful to map uranium, thorium, potassium concentrations over wide areas. This in turn is useful to infer rock types such as granite and zones within rocks that may have been altered by metal-rich fluids passing through. It is extremely important to note that these surveys measure levels of naturally occurring radiation in the rocks, and the instruments themselves do not emit any radiation, making them harmless to both people and livestock. The common instruments used in radiometric method are called radiometer for radiometric prospecting. It consists of a detector, an amplifier or recording unit, and a power unit. The investigation application of radiometric methods are the following: exploration of radioactive substances such as uranium and thorium, location of some rare minerals, geological mapping, exploration of gas and oil, groundwater studies, and many more. In summary, the measured property of radiometric method are gamma ray intensity, radioactive emanation. The units they used are millicurie, microcurie, and alpha particles. The geophysical unit are counts per meter and emans. The measuring instrument and apparatus are different types of radiometer, Geiger-Müller counter, scintillation counter, gamma ray spectrometer, and emanometer. The principle behind this is the natural radioactivity of minerals, of elements. Different methods are gamma method, which is the intensity of gamma rays the body is giving, which is measured. The emanation method, which measures the concentration of radioactive emanations, and nuclear geophysical, which is the artificial intrusion of radiation to a body and measuring the emanation to identify the body. In this image, we can see that there is a low-flying aircraft, which is the helicopter. Within the helicopter, there is an spectrometer or the radiometer, and that measures the area coverage. This is the radiometric method mapping, which consists of different light, or in relation to the light spectrum. This does not measure how concentrated the elements in the coverage area are. Rather, identifying what element there is. The only hint that there is a concentration within this mapping is how distributed the light is. Geothermal method. This method is primarily utilized to produce geothermal gradient of the surveyed area. This is done by measurement of the temperature of the surface of the Earth in shallow holes or in deep boreholes by using thermometers in the boring tube. In principle, temperature distribution on the surface of the Earth is due to three different sources: heat received from the sun, heat conveyed from the hot interior of the Earth due to conduction and convection processes, and heat due to the decay of radioactive minerals in the crust of the Earth. By applying the necessary corrections, it is possible to eliminate the solar heat component and also heat contribution of radioactive mineral decay. After these inclusions, the residual values of temperature distribution on the Earth's surface can be interpreted in terms of subsurface structures, rock formation, and ore bodies. By concept, change in temperature can be measured from the surface downward to drill hole within varying and increasing depths. Additionally, by knowing the thermal conductivity of the rocks, the geothermal gradient can be used to calculate the heat flow. This is the geothermal energy source. The instrument used for geothermal method are thermistors, thermometers, and boreholing equipment. This method of investigation applies to deep structural bodies or deposits, groundwater studies, delineation of saltwater freshwater interfaces, and many more. In summary, geothermal method comprises of measured property, which is thermal conductivity, the measuring instrument or apparatus, which are thermistors, thermometers, boreholing equipment. It also used crystal detectors and radiometric and radiometers. The principle for measuring this method are geothermal gradient. This is a geothermal method process. This is the image represents the geothermal investigation site. This is the boring machine, while this represents the boring tube, which will be inserted to the earth. These yellow circles represents the temperature within the varying depths until it reaches T5. Z represents how deep the material or the temperature is, and this represents the geothermal gradient, which is the partial derivative of temperature with respect to the partial derivative of the depth. Calculating these two, we can calculate for the heat flow.